Welcome to Learn Fast tutorial. In this video, we are going to be looking into differentiation using the quotient rule. When we talk about quotient rule, we are simply talking about a type of differentiation that has something to do with division. And we know that the formula for quotient rule is dy dx equal to v du dx minus u dv dx all over v squared. So this is the general formula when you talk about differentiation using the quotient rule. And we have this problem, x over x plus cos x. We were asked to differentiate this function, x over x plus cos x, using quotient rule. So we know that x is divided by x plus cos x. So we are going to use quotient rule, which is what I've just written down here, to approach this problem. And then we have these variables v and u, which will represent the numerator and the denominator. Now we can choose v to represent the numerator or choose u to represent the denominator. Whichever the case may be, any one you are choosing, just be constant with the one you are choosing to avoid mistakes. So let v be equal to x plus cos x, and let u be equal to x. Now we are also going to look for du dx, which is where we will differentiate u with respect to x, and also look for dv dx, which means we will differentiate v with respect to x. Now since this is our v, we are going to differentiate this to obtain dv dx. So we have that dv dx, which means differentiating v and everything. Differentiating v is differentiating what we have here with respect to x. So whichever thing that has a coefficient of x must be differentiated. But anyone that does not have the coefficient of x, then we will leave it as a constant. And we have x plus cos x. So we have x on both of the on this, or let's just call it a variables. We have x here, so we must differentiate them. But let's take, for instance, we have plus 3 or plus 2 or plus any number that does not have x as coefficient. We leave it as a constant. And so we have x. If we differentiate x, we have 1. Then when we differentiate cos x, we have minus sine x, rather, from our standard integral. If we differentiate cos x, we have minus sine x, and this is our dv dx. So we are going to also differentiate u with respect to x, and when we differentiate u with respect to x, we have 1 because u is x, and when we differentiate this, we have just 1. And going forward, we then have to substitute everything we have here into our main formula. So we have that dy dx will be equal to, we'll have v to be x plus cos x, and then we have du dx to be equal to 1. Then minus u, we'll have u to be x, and then we also have dv dx to be 1 minus sine x. So we are going to multiply all these together, and do not forget, we are going to divide everything here by the square of v, and note that the v is x plus cos x, so we are going to square x plus cos x. We are dividing everything by s plus cos x squared. So we have that dy dx will be equal to, when we multiply everything by 1, we have x plus cos x. Then do not forget we have negative x here, times 1, we have negative x. Then when negative x multiplies by negative sine x, we have plus x sine x. So we're dividing all through by x plus cos x all squared. Now we can take out positive x and negative x. So leaving us with dy dx will be equal to cos x plus x sine x all over x plus cos x all squared. So this is the answer to this problem that we'll have here, x over x plus cos x. This is the correct answer to this problem. You need to also always look out not to make mistakes trying to substitute your numerator and your denominator for any of these variables. So thank you for watching. Make sure you share this video to your friends. Follow our page, like our page, and subscribe to our channel. Hope to see you on our next class. Bye for now.